Good afternoon, everybody. This is Megan, and as part of our discussion this week, we're supposed to be talking about the similarities and differences between the different types of correlations. So, the first correlation is the bivariate correlation, and the book defines that as the correlation between two variables. So, what this does is it determines the strength of the relationship between the two variables. So I like to use examples when explaining things, and so I thought the example in chapter 7 of the textbook was a really good example. So the two variables they used were advertisements watched and packages of sweet spots. So in the study, they showed, I think it was 5 participants, and they showed advertisements of these sweets, and then the following week they measured how many packages of sweets they bought. So in order to find the bivariate correlation, the first step is to multiply the standard deviation of the advertisement watched and the standard deviations of the packages of sweet spot. And all of this is found in the book. It's around page 265. So the standard deviation of the advertisements was 1.67, and the standard deviation of the packages of sweet spots was 2.92. And so multiplying those together, you get 4.88. So then the second step is to divide the covariance, which is the average sum of the combined deviations from the mean of both the advertisement watch and the packages of sweet spot. And then I put on there, see page 265 in the textbook to figure out how to do the covariance. So we divide the covariance, which in this example was 4.25, divide that by our 4.88, and we get our answer to be 0.87. So now that we have our answer, what does that mean? Well, so we're going to interpret the results. If you get a -1, that means that it's a perfect negative correlation. So as one variable increases, the other variable decreases. A +1 means that it's a perfect positive correlation. So as one variable increases, the other also increases. And then if it's 0, that means the variables don't have any relationship at all with each other. So as one variable changes, the other one just stays the same. So in our example, we got 0.87. So in my mind, I'm thinking that is a positive correlation. So as for our example, as the number of advertisements watched increased, also the number of packages of sweet spot also increased. So the more advertisements watched, the more packages of sweets were bought. So that's how I'm thinking of bivariate correlation. The next correlation is biserial correlation, and it is used when one of the two variables is dichotomous. And dichotomous means that it is categorical. The variable is categorical with only two categories. So the book gave two different examples. A point biserial means it's discretely dichotomous. So it's either or, like a female is either pregnant or not. They're not either kind of pregnant or not really pregnant. They're pregnant or they're not pregnant. And then the other example is the continuous biserial correlation. And they gave the example as pass or fail an exam. Yes, the person passed or you fail, but they could have passed by a lot. They could have got 100, they could have gotten a 90, or they could have barely passed. Maybe if a C is passing, they barely got a C, they almost got a D, but they got a C. Or if they failed an exam, did they get a 0 on the test, or did they just barely fail? So that's what it means to be continuous biserial correlation. The next correlation is the partial correlation, and this is the one that took me the longest to understand, and I'm not sure that I still fully understand it. So the book defines partial correlation as a correlation between two variables in which the effect of other variables are constant. And again, I do better with examples. Just reading that definition still, I'm kind of confused. But the variables that the example gave had exam performance, exam anxiety, and revision time. So I was looking at how revision time and exam anxiety affected exam performance. So a portion of variation is shared between both exam anxiety and revision time. So how I took that as people didn't just have exam anxiety, or their exam performance didn't just deal with their anxiety. It also dealt with revision time, or that's what the study was looking at. It was looking at both, not just one or the other. So in order to do a partial correlation, we have to remove the portion of the variation shared. So my example is remove the portion of the variation shared by revision time in order to just measure exam anxiety on exam performance, and then vice versa. It helps us to find the size of the unique portion of variance, and it also controls the effects that the third variable has on both variables in the correlation. So if we're just wanting to look at exam anxiety on exam performance, we need to kind of take into consideration that revision time probably also had a combined effect on exam performance. So we want to kind of see just exam anxiety and exam performance. So I'm still a little confused on that. So hopefully by watching everybody else's videos, it can kind of help me out a little bit. So the last correlation is the semi-partial correlation. And the book defines that as the control for the effect that the third variable has on only one of the variables in the correlation. And the book also used the exam performance, exam anxiety, and revision time as an example as well. And the semi-partial correlation, it helps control for only the effect of revision time on exam performance, and the effects of exam anxiety on exam performance are ignored. So I guess if you want to be looking at revision time and exam performance, you would just take out exam anxiety on exam performance and just ignore that, because we just want to look at revision time and exam performance. So all in all, I think the semi-partial and the partial correlation were definitely the most confusing for me. I still am not sure I have a complete grasp on it. Obviously, the semi-partial and the partial ones are dealing with 3 variables, whereas the bivariate and the biserial are only dealing with 2 variables. I thought the bivariate correlation was the easiest one for me to learn because it was kind of cut and dry. It's mathematical, whereas these, it's kind of trying to wrap my head around it. So I'm looking forward to seeing what everyone else comes up with for this discussion.